Now, apart from these important concepts, there are a few other keywords and terms we need to know. Some of the important keywords related to relational models are indexing and query optimization, constraints and triggers, views and materialized views, relational model extensions, data migration and integration, database administration and performing tuning. So let us discuss all these terms one by one and understand what role they are playing in database management system. Indexing and query optimization. Indexing in database management system involves creating data structure like B trees or hash tables to efficiently retrieve data based on specific criteria. Improving query performance, it organizes data for quick lookup, reducing search time and resource consumption. Query optimization enhances database performance by selecting the most efficient execution plan for queries. Techniques includes parsing, rewriting, and cost-based optimization. By analyzing query structure, statistics, and available indexes are optimizer time to minimize resource usage and maximize query performance. Together, indexing and query indexing and query optimization streamline data retrieval, ensuring faster query execution and improved overall system efficiency in database management system. Indexing optimization. In the relational model, indexing involves creating data structure that allow for faster retrieval of records based on certain attributes. Indexes are typically implemented as a B tree or hash structure, facilitating rapid lookup operations. Common index type includes primary key indexes, which enforce uniqueness and facilitate efficient record retrieval, and secondary indexes, which accelerate searches based on non-primary key attributes. By using indexes, the database management system can quickly locate records without scanning the entire table, significantly improving the query performance. The next is query optimization. Query optimization involves DBMS as an internal process of generating an efficient execution plan for executing structured query language queries. This plan aims to minimize the query's execution time and resource consumption. Optimization techniques include cost-based optimization, where the database management system evaluates various execution strategies based on estimated cost, such as disk input output, CPU usage, and select the most efficient plan. Techniques like a join recording, predicate push down, like join recording, predicate push down, and indexes selection. Techniques like joining recording, predicate push down, and index selection are employed to optimize query execution. Query optimization is essential in relational databases to ensure that queries are processed quickly and that system resources are utilized effectively. The next term or keywords are constraint and triggers. In the relational model of database management system, constraint and triggers are tools used to enforce rules and automate actions within the database. Constraint in relational database enforce rules on data like ensuring uniqueness or referential integrity. They prevent invalid data from being inserted or updated. Triggers are omitted. Triggers are automated procedures triggered by a specific event, such as data manipulation or data action. They can enforce complex business rules, audit changes, or automate tasks. Constraints maintain data integrity by defining acceptable values or conditions, while trigger automate action based on a specific event, enhancing the reliability and functionality of the database system. Next is constraints. Constraints are the rules that define the acceptable values or conditions for data stored in the tables. They ensure data integrity by preventing the insertion, deletion, or modification of the data that would violate these rules. Common type of constraints may include primary key constraints, foreign key constraints, unique constraints, check constraints. Let us take primary key constraint. Ensure each row in a table has a unique identifier. Foreign key constraints enforce relationship between tables by ensuring values in one table match the value in other. Unique constraint requires value in a column or combination of a column to be unique. Check constraint, a specific condition that data must meet to be valid. Next is triggers. Triggers are special procedures that are automatically executed in response to specific events or action in database. They can be triggered before or after data manipulation operations. Example, insert, update, delete. Or database related events, for example, shutdown. Or database related events, for example, a startup and shutdown. Triggers can be performed a variety of tasks such as enforcing complex business rules or data validation logic, auditing changes made to the database by recording details such as who made the change and when, facilitating data replications by automatically updating copies of data in other database or tables, performing additional actions such as updating related records or sending notifications based on specific conditions. Constraints Constraints are rules defined on column or table to maintain the data consistency and accuracy. They enforce certain conditions on the data, preventing the insertion, updation, or deletion of invalid or inconsistent data. Now the next keywords are views and materialized views. In the relational model of database management system, views and materialized views are virtual tables that provide a customized perspective of the data stored in one or more tables. Views. What is views? So the views are virtual tables generated by executing a query against one or more base table. They do not store data themselves, but rather display data from the underlying tables based on the defined query. Views can present a specific column rows or aggregated data, making it easier for user to access and manipulate the data without directly interacting with the underlying tables. They offer a way to simplify complex queries, enhance security by restricting access to sensitive data, and improve data consistency by centralizing commonly used queries. Materialized views. Materialized views, on the other hand, are pre-computed and stored copies of the result set of queries. Unlike views, materialized views physically store data, allowing for faster query performance because the results are already computed and stored. Materialized views are periodically refreshed to synchronize with changes in the underlying data. They are beneficial for improving query response time. They are beneficial for improving query response times in scenarios where the underlying data is large or complex, as they reduce the need to repeatedly execute resource intensive queries. However, they consume additional storage space and may require additional maintenance to keep them to update. The next topic of discussion is relational model extension. In relational model of database management system, relational model extension refer to additional features or capabilities that extend the basic functionalities of the traditional relational model. These extensions allow for more complex data modeling and manipulation capabilities beyond what is provided by the core relational model. Relational model extension in database management system enhance data modeling flexibilities with support for complex type, inheritance, and temporal data. Additionally, constraints, variations, and triggers automate actions catering to diverse database requirements in modern applications. Some common relationship, some common relational model extension are include object relational extension. Next is constraint extension, triggered and stored procedure, temporal extension. Let us take one by one. Object relational extension. These extensions allow the relational model to support complex data types such as an array, XML, and spatial data. They enable the storage and manipulation of non-standard data types within the database, providing greater flexibility in data modeling. Inheritance. Inheritance allows tables to inherit attributes and behavior from the other tables, similar to object-oriented programming concept. This extension enables data modeling with hierarchical relationships and facilitates code reuse and abstraction. Constraint extension. Additional constraint types such as assertion constraints can be included to enforce more complex integrity rules on the data. Assertion constraints allow for the specification of conditions that must be true for database to remain consistent, providing greater control over the data integrity. Triggers and stored procedures. While not exclusive to relational databases, triggers and stored procedures can be considered extensions of the relational model. They enable the extension of custom code in response to specific events or action within the database, facilitating automation and business logic implementation. The last is temporal extension. Temporal extension allows temporal extension allow for the storage and manipulation of temporal data such as valid time and transaction time. They enable the tracking of historical changes to data over time, supporting applications that require historical analysis or auditing. Database migration and integration. Database migration and integration in a relational model of database management system involves transferring data and consolidating data from one system to another or integrating data from multiple resources. Database management system involves transferring the data and consolidating databases from one system to another or integrating data from multiple resources into a single unified database. So first we will discuss the database migration followed by database integration. So database migration. Database migration is the process of transforming data. Database migration is the process of transferring data, schema, and other database objects from one database system to another. This may involve migrating from one DBMS platform to another. For example, from from Oracle to MySQL, upgrading a newer version of the same database management system, or moving data from one premises server to cloud-based platform. Migration often requires careful planning, data validation, and testing to ensure that data integrity and minimize downtime. And testing to ensure data integrity and minimize downtime. Database integration. Database integration involves combining data from multiple sources or databases into a single unified database. This could include integration data from different departments within an organization, merging data from acquired companies, or consolidating data from various applications or systems. Integrating may require data cleaning. Integration may require data cleansing, transformation, and mapping to ensure consistency and compatibility across different data sources. It aims to provide a unified views of the data for analysis, reporting, and decision-making purposes. Both database migration and integration in the relational model aims to streamline data management process, improving data consistency and accessibility, and facilitate data-driven decision making within and organizations. They play a crucial role in ensuring that data remains accurate, up to date, and accessible across different systems and applications. Database administration and performance tuning. Database administration in the relational model involves managing users, account, security, backup, and schema modification to ensure data integrity and security. Performance tuning optimize database performance by analyzing and optimizing queries, indexing, and database configuration. These processes enhance data processing speed, resource utilization, and system reliability. By efficiently administering database and tuning performance, organization can ensure efficient data management, reliable operations, and optimal performance in their relational database management system. If we discuss them in detail, then first we see what is database administration and then performance tuning. Database administration. Database administration encompasses various tasks such as user management, backup and recovery, security management, monitoring and maintenance, schema design and modification. Let us start one by one. User management. Creating and managing user accounts, roles, and permissions to control access to the database. Backup and recovery. Implementing strategies to regularly backup data and restore it in the case of data loss or corruption. Security management. Implementing security measures to protect the database against unauthorized access to security threats. Monitoring and maintaining. Monitoring database performance, diagnosing issues, and performing routine maintenance tasks to ensure optimal performance and reliability. Schema design and modification. Designing and modification. Designing and modifying database schemas to meet changes. Designing and modifying database schemas to meet changing business requirements and optimize data storage and retrieval. Performance tuning. Performance tuning allows optimizing database performance to ensure efficient data processing and response time. This includes query optimization, indexing, and data configuration, hardware optimization, and database design. Let us we take one by one. Query optimization, analyzing and optimizing database queries to improve execution speed and resource utilization. Indexing, creating and maintaining appropriate indexes to speed up data retrieval operations. Database configuration, adjusting database configuration parameters such as buffer size, cache setting, and concurrency level to optimize performance. Hardware optimization, optimizing hardware resources such as CPU, memory, and storage to ensure adequate performance and scalability. Database design, designing and optimizing database schema, data model, and relationship to minimize data redundancy and improve query performance. In today's lecture, we discuss about the relational model concepts, relational model constraints, and integrity constraints. Now let us access your knowledge and track your progress with some important questions. Your answer will enhance your concepts as well as make you more aware about the topic. The today's question to test your knowledge are: what do you mean by relational model concepts and explain in detail? Explain relational model constraint in detail. What is the primary purpose of constraints in the relational model of database management system? What are the integrity constraints in database management systems and how do they ensure what is and how do they ensure data integrity and consistency? In our in our exploration today, we have navigated the intricate world of data modeling using the relational model concepts, relational model constraints. In today's lecture, we have discussed so many important topics which will help you in your academics as well as information industry. I hope you enjoyed this lecture. I hope you enjoyed this lecture. Hope to see you soon in the next lecture. Thank you very much.